Hi and welcome to this section where we are going to start looking at finite difference operators. So we'd like to start by saying that for a function y is equals to f of x, okay, we will describe y0, y1, y2 and so on up to yn to be the values of the variable y, okay, of this variable y, corresponding to the equidistant arguments x0, x1, x2 up to xn, okay, where we will define, okay, we'll assume that x0 is known, so we'll define x0 to be equal to, x1 to be equal to x0 plus h, and x2 to be equal to x1 plus h, but we already know x1 is x0 plus h, so this is going to be x0 plus h, which is going to be x0 plus 2h. Similarly, x3 will be x2 plus h, and then you make the substitution, so you'll find out that it is going to be x0 plus 3h. So generally we shall write that until xn, which is x0 plus h, okay. So the finite difference operators deal with changes that take place in the values of the function f of x or our y, okay, and our value of the function f of x, which is represented by y, due to finite changes in our variable x. So we look at the changes in y due to finite changes in this variable x. That is what we look at finite differences. They are very important, as we shall later on see in our subsequent discussions. Now, the finite difference operators which we are going to look at will include, we shall look at the forward, okay, then we shall look at the backward, and what else? We shall look at the shift operator and the central difference operator. We shall look at the shift and the central difference operator. Okay, perhaps we could also look at the mean operator if we have time, but then if we have already got the idea with this, then we may decide to skip the rest, okay. So now we could start that for the values y0, okay, let us now start by formalizing it here by saying that for the values y0, y1, y2 up to yn, for the function y equals to f of x, okay, for the equidistant points which we have already described earlier on, x1, x2 up to xn, okay, the forward difference operator defined on the function f of x, written as this. The forward difference operator is denoted as that, okay, defined on the function f of x, okay, is, okay, at the point defined on the function f of x at this point xi is going to be defined as f of xi plus h minus f of xi, okay. We know, or we can write this f of xi plus h, we can write it in this form where we shall write f of xi plus 1, okay, minus f of xi. Why do we write f of xi plus 1? Because we know that f of xi plus h is just going to give us the next, point. If this is x0 and this is x1, okay, if this is xi, then this is xi plus 1 and this is h, okay. So that is why we're saying that we can always write xi plus h to simply be the one which is going to give us that point f of xi plus 1. Okay, so we can also write this as, okay, the forward difference operator, just terminology, because f of xi, we can say it is yi. Okay, since y equals to f of x, then we can as well say yi is f of xi. So we can write this to be just that, and then we can write the next one there to be yi plus 1 minus yi. Okay, we can also use this notation here, and these are exactly the same. Okay, then now in particular, let us assume that our I is 0. Okay, let us assume that we are starting right at the start point where our I is 0. So about this, we could draw a proper straight line. So let us assume that we are starting at x naught, okay, where our I is 0. So we can write and then say that the forward difference operator at f of xi, where our I is 0, just here, this point here, we say it can be written as f of xi, which is x naught, that is x naught plus h, minus f of xi, which in this case, which is x naught. Okay, but we know that f of x naught plus h is the same as x1. So we have f of x1 minus f of x naught. So if we are here and we want the forward difference operator, we simply take the value here of the value of the function at x1, and then we subtract the value of the function here at x naught where we are. Okay, and so also we can also write this in the other terminology if we are going to use y, the forward difference operator at y naught, because this is y naught and this is y1. Okay, it's simply going to be y1 minus y naught. So we can see that what about the forward difference operator at x1? We know that this one is simply going to be f of x1 plus h minus f of x1. Then we can make the substitutions in terms of x naught and so on. Okay, we can okay as well say this is f of x1 plus h. We know this is f of x2, and then this is going to be f of what? x1. We know this is h, and this is h. This is x2. So x1 plus h is x2. That is what we are writing here. Okay, and we can also write this and then say that the forward difference operator at f of x1, which is the same as y1, is simply going to be f of x2, which is the same as y2, minus f of x1, which is y1. Okay, so the forward difference operators, this one here, forward difference operator y naught at y1 and so on up to yi, are known as the first forward differences. Okay, we shall look at the table and then see how we can make this, generate these first forward differences. And then the second forward differences, so we want to find the second forward differences, is denoted as that at xi is simply going to be the first forward difference of this first forward difference. Okay, so we know that we are going to look at the forward difference here. Oh, these ones are fast forward differences. Okay, now this is the second. I hope I am not confusing anyone. I hope I have used the right word. I thought I may have said something not so fine, but if you listen to the recording later on and you find any mistake, please put it in the comment section. So the second forward difference operator is going to be the fast forward difference of this fast forward difference. Okay, it's just like a composition here. All right, so but we already know what is inside here, the fast forward difference. What is the fast forward difference at xi? It is going to be f of xi plus h minus f of xi. So now we can say that we are taking the forward difference of xi plus h minus the forward difference of f at xi. So we know that the forward difference here is simply going to be, we look at the next point, that is f of xi plus h, that is the point, then we look at the next point, okay, minus f of xi plus h, then minus this one here, which we have, it is f of xi plus h minus f of xi, and we have to put it in brackets. Okay, then we can simplify this and then say this is xi plus 2h, then minus f of xi plus h, then minus, this is going to be f of xi plus h, and then the minus, and this minus we have plus f of xi. Okay, so we can as well write this and then say it is going to be f of xi plus 2h minus 2 f of xi plus h, then plus f of xi. And what was this? This was the second forward difference at xi. So using our terminology, we said this is going to be at yi. Okay, this one here, f of xi plus 2h is xi plus 2, then minus 2 yi plus 1, and then this is minus yi. Okay, so if we want to find this at x naught, in other words when I is 0, you can just write it here as this. So yes, when I is 0, so this is going to be y2, okay, minus 2 y1 minus y0. So we can go ahead and even find the third forward difference in the same way. Third forward difference at xi is simply going to be that composition of the first forward difference. So let us break it down. Maybe say it is the first forward difference of the second forward difference at xi, but we already have this expression here. You can pick it from this and then try to substitute in here and follow the proper algebra. Okay, that can be quite a little time consuming, but please verify what is in the notes, that it is yi plus 3 minus 3 yi plus 2 plus 3 yi plus 1, or check for any errors. Okay, and then in particular we'll come up with the nth forward difference operator. We can see a general pattern if you do that for quite some time. The nth forward difference operator, and well, do I need to write this? Maybe no, yes, maybe not. Anyway, you can check it out in the book. the nth difference operator at xi is going to be given by this xi plus h minus that f of xi. Let us try it out for what we already know, for a result we already know, if we are looking at the second. So that means that if we use this formula here, the second here is simply going to be the first at xi plus h minus the first at xi, because this is n minus 1, this is 2 minus 1, 2 minus 1, which is 1. Okay, so this one here, it's the same, because it is giving us what you already know. The first forward difference at f of xi plus h is simply going to be f of xi plus h plus h, that is 2h minus f of xi plus h, then minus this one here. So we see it's what you already have, xi, then minus f of xi, then it reduces to what we already have. So yeah, you can have this general formula which we derive. Okay, it can help you remember this. So we can write these first forward differences in a table form as follows. Okay, so I'll just have a column here, then I have a second column, then we have a third column, then we have a fourth. Okay, I can stop here, and so on and so on. Oh, maybe let me just do this. Okay, so let's see. So we have here our values of x, okay, and then we have y, which we know is equals to f of x. Should I put xi? Maybe. And then yi is equals to f of xi, and then this is the first forward difference, yi, and then this is the second forward difference, and then this is the third forward difference, and so on. Okay, so here we can start. Maybe we have x naught, perhaps we have the value x1, then we have maybe x2, x3, and so on up to perhaps xn, wherever xn is. So we know this is y naught, which is f of x naught. This is y1, which is f of x1, and then this is y2, which is f of x2, and this is y3, which is f of x3, and so on. So we have seen that the first forward difference here at y naught, first forward difference at y naught is y1 minus y2, the value here minus the value here. The first forward difference at y1 is simply y2 minus y1, the value here minus the value here, and so on. So no prizes for guessing that the first forward difference at y2 is y3 minus y2, the value here minus the value here. So it goes on and on and on. The second forward difference, okay, at y naught, okay, is simply going to be at the second forward difference at y naught is simply going to be the first forward difference at y1 minus the fast forward difference at y0. Okay, let's try this. Remember, we are saying that the fast forward difference at y0, the first entry in here, is going to be the fast forward difference at y1, this one here, minus the fast forward difference at y0. Indeed, it is just this minus that. Okay, let us complete it here because we already know this result. So we are saying that it is y2 minus y1 minus y1, then minus, and this negative becomes a positive y2. And we know this is y2 minus 2y1 plus y2. And I am sure we have already seen this result here, y2 minus 2y1 plus y2 minus 2y1. Okay, y2 minus 2y1 plus y2. Did I say y2? Yes. No, something is not right here. This is not y2. Okay, sorry. This was confusing me here. The fast forward difference here is y1. The fast forward difference at y0 is the value here y1 minus the value here y0. So I am honestly very sorry. I don't know why I wrote y2. This is y0. I hope everything else is now correct. This was really confusing me. So this is y0. This is y0. This is y2 minus y1 minus y1 minus y0. y2 minus y1 minus y1 minus y0 gives us y2 minus 2y1 plus y0. Okay, and this is what we already have somewhere here. Yes, this one here, y2 minus 2y1. Then this is supposed to be a plus, right? Okay, I'm making so many mistakes here. So this one was supposed to be a plus. I think so, because when we open the bracket somewhere here, that sign should have changed. Yes, here. Yeah, we already have it. It's already a plus here. Okay, so I'm not so sure why I made it a negative here. It is supposed to be a plus, because we have already seen here that when we open the brackets here, this is this one, the first one, then the second one, then the negative, and this positive will give us the negative, and then this negative and this negative has to give us a what? A positive value, this one here. Okay, so I'm sorry about that, but it is good I went back and checked within the same video before uploading it. So that is what we do. And then also here, similarly, the second forward difference at y1 is simply going to be the first forward difference at y2 minus the first forward difference at y1. In other words, to get the value here, we simply get this minus that. Okay, so it is just the same. To get the value here, I will just get this minus that, and so on. And so we go on and on and on until we complete the table. So next is a simple example which we would like to conclude with. Okay, we have values of x, and then we have values of f. So we have that. Okay, so we have values of x, and then we have values of f, that is f of x. Okay, so we have 0.1, 0.3, 0.5, 0.7. So we see that the equidistant h is 0.2, and so on. So you have values here, maybe 0.003, 0.06, 0.067, 0.148, and then this is 0.248, and then this is 0.370, this is 0.518, and then under 1.3 we have 0.697, and so on. So what you're going to do is follow the in the let me just do this very fast because we have run out of time. So we have x, then f of x, then the first forward difference, then the second forward difference, and so on up to the fast forward, the forward difference which they have told you to end, okay, up to whatever nth forward difference the problem is asking you to end. So x, you just fill in the values here. This is 0.3, this is 0.5, and so on and so on. So corresponding values for f, this is 0.003, this is 0.067, this is 0.148, this is 0.248, this one 0.7, and so on. Then the fast forward difference here, we simply know it is 0.067, the value here, minus 0.003. Then to get the fast forward difference here, you just get this minus that. To get the fast forward difference here, you get this minus that. To get the second forward difference here, you simply get the value you got here minus the value you got here. Second forward difference here, the value here minus the value here, and so on. So you can please follow through the table and construct the forward difference table for the corresponding values using those examples, okay? So in case there is any problem, you can please put in the comment section or ask and you'll get help, okay? Thank you and see you in the next video.